Hello, thank you for subscribing and supporting Infowars Tech. As my subscribers are aware, this is a channel where we explore new trends in technology, ranging from big data, machine learning, artificial intelligence, Python programming, and similar topics. Today we're going to look at a very interesting database which comes built in Python. It's called SQLite. It's a C library that provides a lightweight, self-contained, disk-based database. As you can see, I'm showing the SQLite homepage where we can read more information about it. So the interesting thing is that it comes bundled with Python and can be used in any Python application without having to install any additional software. It's also possible to prototype an application using SQLite and then port the code to a larger database such as Postgres or Oracle or MySQL or any one of those databases. Since SQLite is used extensively in every smartphone, it's estimated that over 1 trillion databases are in active use. So it's an amazing piece of code, and today we're going to see how we can use it inside Python, create a table, create a database, add some data into it, and then query that data and be able to change that data. So I'm going to show all of that. And again, this is a basic tutorial on SQLite. If you want to explore further, I would direct you to go to this page, which is the SQLite where with all the commands are and the API specification and all. And most of the tutorial that I've created has been derived from referencing this website. So again, do make sure to reference these two websites, and I'll also add a link to these in the tutorial. So let's start. Just before we do that, I just also like to let you know that SQLite is found nearly everywhere. Android devices, iPhone, iOS devices, Macs, Windows 10, Firefox, Chrome, all of those browsers, Skype, iTunes, a Dropbox client, you name it, it's in millions of applications. So it's a great piece of technology, and does require some this tutorial will require some basic understanding of SQL to go through the commands that we will be displaying here on the screen. So just a quick introduction to this tutorial. We will be using Jupyter Notebooks. I have that open right here. As you know, I've used Jupyter Notebook in most of my tutorials in Python, and I think it's a very good platform to use. We'll go through the SQLite3 module in Python 3. We'll create a connection to a SQLite database, add a table, insert data into that table, and read and modify data in that table. So I hope to keep it short so that there's maximum learning, and then you're able to go on and explore on your own. And I guess that's the basic objective. So let's get started. As you can see, I have opened a Jupyter Notebook. I've already created, just given it a name, Python _SQLite3 tutorial. So let's get started. The first thing that we need to do is to import the SQLite within using this command, and I'm going to run that, and then I'm just going to create and just quickly about what we're going to be creating on the database. It's going to be an inventory of cryptocurrency held by a fictitious investor, right? We're just going to create a fictitious but the pricing will be, and the names of those cryptocurrencies will be real. However, it's just some random number that owned by an investor. So the first thing that we need to do is create a connection to that database. So I'm just putting it here. So I'm giving it a name, connection, and that equals SQLite.connect, and the database that I have is I'm calling it crypto.db, and this is actually file based. It resides in the current working directory. So we go ahead and run that. Now we have that stored in the connection. The next thing that we use is something called cursor. Cursor is used to execute SQL statements and fetch results from those queries, and it's also called an object database object cursor. So we'll see how that's used. So all we need to do is run this command, which is cursor equals to the connection that we just created, dot cursor, and that will create that cursor object. So let's run that. Now we will be able to use the cursor object to run SQL queries. Okay, so let's go ahead and create a table, and I'm just going to explain what that is going to do. So I'm doing a cursor.execute, and I'm running create table crypto. I'm just going to go through that. So anyone familiar with the SQL will easily recognize this SQL statement, which is saying create a table, give it a name crypto. One of the fields, so it has 4 columns. You can see name, symbol, price, and number of coins. And in front of each of them we have the type. So name is text, symbol is also text, price is real, and number of coins is also going to get a real value. And over here we can just take a quick minute to talk about SQL and Python data types and their relationship. So in Python, if you use int for an integer, in SQLite it's also integer, integer. We spell the whole word. In Python we use float, and the corresponding data type in SQLite is real. So that's what we are using here, because we expect the price to be in decimals at times, and also the number of coins, especially in crypto. As you know, we can do, or we can buy and sell in fractions. So that's why both of these are real. And additionally, str string in Python translates to text in SQLite, as well as bytes in Python translates to blob in SQLite. So that was just a quick recap on the data types that are common or are mapped between SQLite and Python. So here we're creating this table crypto, and we have 4 columns. So let's go ahead and run that. So that should be created. Now let's insert some data. So I've already pre-populated, and I'm just going to run that. Okay, so seems I might have closed it at the end of the previous exercise. So let's do this. Let's create another, and let's call it crypto2. It doesn't matter, it's just a name that we give it, and I just need to run that again. Let me run that again, and over here I can call it that's fine, it can be table crypto on that new database, which is crypto2. Okay, so that seemed to run. Sorry about that. I believe when I was preparing this tutorial, at the end of the practice, I would have logged the database, but that's fine, we are good to go. So I'm going to now pre-populate this data. I have that written down already, so let me just paste it here, and we can have a quick look at it. So what we're doing is we're doing a cursor.execute. Remember, the cursor object allows us to execute SQL commands and send in queries. And again, anyone familiar with SQL will recognize the insert. So insert, create, these are all keywords in SQL. So what we're doing in the first line here is insert into crypto values which include the name is of that cryptocurrency is Algorand, the symbol is algo, this is the current price, and this is the number of coins held by that fictitious investor. Similarly, in line 2 we have Shiba Inu, that's another altcoin, and the symbol is SHIB, and so on. So you can see that I have about 6 of these different listed here. I'm just going to run this, and so that ran well. All of those are now in the database. So let's take a quick look. We can also do a connection.commit, which is good to execute right after insertion so that those transactions are committed. So let me just quickly run that. Okay, now let's see what we saved. So to do that, we're going to run this command, which is basically just rows as another variable that we've chosen. It's saying cursor.execute, select, again this is an SQL keyword, select name, symbol, price, number of coins from crypto, and the dot fetch all says fetch all of the information, and at the end we say print that all the information that's contained in the rows variable that we have selected here. So let's run that, and as you can see, those 6 coins in that data was successfully inserted into the table. So we can see that that operation was successful. Now there's another way to display this information, and that's using people familiar with Python would recognize that's stepping through each of those values and then displaying them using the for command. So let me just write that here, and do note that there's an indent because there's a for statement. There's an indent for the print. So what we're doing here is for row some variable in cursor.execute, select all from crypto. So it's just going to step through each row and print it out on the screen. So this is another nice way and quicker way to print the same information that we got using this command. So just to show you various ways of running that output or getting that output. Now let's run a query to match a record in the database. So as a test, what I've selected here is to search on Algorand. So what we are basically doing is that you're running the select name, symbol, price, number of coins from crypto, running it on that table, and we are trying to see in all of those rows. And remember, our database could have millions of rows. So what we are doing is we want to query the database and return where the name matches Algorand, right? And then we want that all of those rows to be fetched. So let's run that, and you can see that that query was successful because we do indeed have a record in the database, the table, which has a name called Algorand with the symbol algo and the price and the number of coins, and that's returned as part of the data. Now we can also run a query to match a certain range. So let's see what so I'm just making these up. You can certainly, when you view this tutorial, you can use your values and it would run fine. Here what we're doing is we're selecting all the columns, and we're saying the number of coins is greater than 5,000. So let's run that, and as you can see that it returned Algorand, Shiba Inu, Dogecoin. So this investor has 3 of these cryptocurrency, and their numbers, 3 of them have he owns over 5,000 each of those, right? Greater than those, which is what this is denoting. So if you read this, it select all these columns from the table crypto, where again, where is an SQL statement, number of coins is greater than 5,000. So out of those 6, it runs, and it gives us an output of 3, which match that that query. Now let's run another one where we are trying to say, show us all the coins or all the cryptocurrency where the number of coins is less than or equal to 10,000. So when we run that, you see it picks up I see Chainlink and Ethereum and Bitcoin. So again, you can see that if it matches by the number of coins. So here's 7,500, 2.5 for the BTC, 65, and all of these are under 10,000. That's why it returned that. You will note it didn't return Shiba Inu because it was more than 10,000. It's like, I think, 25 million or something. Okay, let's run another query where we are finding rows which match between 2 ranges. So again, I'm making this up. I'm just and we could maybe change that. So here we are using the between command, and I believe this is also an SQL command, and we could write that in capital just to show that. So select all the 4 columns from crypto, the table, where number of coins is between 100,000 and 2.5 million, and fetch all the rows that match that. So when we run that, we don't get anything. Okay, so let's change that a little. Let's make that, let's say as an example, so I'm looking for all the number of coins which are between 1,000 and 2.5 million. Let's run that. And as you can see, we got a few hits. So we got Algorand, we got Chainlink, and we got Dogecoin. These are all that lie between that, and we can rerun this, and you'll see that you'll get a different result each time. As you can see here, I reduced the range, so I also able to pick up Ethereum and Bitcoin as an example. Now there's might be a requirement to change the value. So this investor, or crypto investor, perhaps sold some cryptocurrency, or he bought some. Here I'm saying I want to update, which is an SQL statement, crypto in the table, and set the number of coins to 8,500, where symbol is algo. So if you remember, currently this investor has 6,500 algo, and once I execute this, it will update the number to 8,500. So this is some update going on in the database, and it's reflecting his current status. So he's perhaps bought 2,000 algos more, and that needs to be updated. So when we run that, let's run that. Sorry, let me select this and run that. So that ran successfully. Now let's run the fetch all to see that change, and let's run that here. And if you notice, it used to be 6,500, so this investor bought 2,000 more, and now we were able to use the update command of SQL to change it to 8,500. If we see that in the other method that we have, we can execute that, and you can see that Algorand has been updated to 8,500. So these are the SQL commands or SQL statements that allow us to make these changes. Okay, let's look at some other examples where we might need to count the number of rows. So let's see what is the format for that command and how we can run that. So again, rows using cursor.execute. We are selecting all, so * stands for all from that table crypto, and we are printing the rows.fetch all, but we're also taking the len. So len is short for length. It's a Python command. As long as it's within these parentheses, it will print out the number of total rows that were returned. So when we run that, it's 6, which we know is correct because we have 6 data points or rows in our database currently. We can also query and sort the results. So if we run this command, let me just show it here. So we're running that command, and we are selecting all the 4 columns, and we want to order it by the price. So when we run this, it's going to do ordering by price. So it's just taking this into account, and it's always in the ascending order, right? So it was Shiba is the smallest cost, and then Doji at 0.67 cents, .51, 51 cents, and so on, right? We can also change this to, let's say, if you want to order by the number of coins, so we can just change this. And when we run that or rerun this, you'll notice that it's now ordering it by the number of coins owned by this investor. You can see it again. It's matching that number. So the lowest holding is BTC, 2.5, and the largest that we have is Shiba Inu, which is like 2.5 million. Now we might need to see it in the reverse, right? Like descending order. So we can simply run this command, and it will rerun that, and you can see that now it's in descending, right? And we ordering by price, you can see it's now highest is 20,000 for BTC, and then it goes all the way down to Shiba Inu. Now another thing, you notice that here we had to run these 6 different lines, or 6 different commands to enter data. What if we have a large number of data or rows to enter? For that, we use a command called execute many, and let's see how the format is. So for this command, let's say we have all of that data in some variable called data. I've pre-populated it, so we are showing 3 more cryptocurrencies here: Cardano, Stellar, Polygon, and this is the format. So data equals, we open this square bracket, and we enclose all the data points that we need here. Make sure that it should match the table format. So this is the name, this is the symbol, this is the price, and this is the number of coins. And then we run cursor.execute, and this time we say many, and we are inserting into crypto values which are represented. So since we have 4 columns, we are representing it by these 4 question marks, comma, the actual data that will be populated. So when we run this, it runs successfully, and we are able to see that. So we can run a fetch all to see that now we have added the Stellar, Polygon, and ADA appended at the end of the table. So this is a great way to enter multiple rows into the database. Now we can also delete a row of data from a table. Again, we saw how we could update, and update does an in-place update, so it changes the value of that row. But we can also delete the let's say this investor sold off some of the cryptocurrency, so it's no longer in his doesn't show in his database, so we can go ahead and delete that. Let's see what is the command for that. And again, we will be using delete, which is an SQL statement. That's a keyword from SQL. So rows equals cursor dot execute delete from crypto where symbol equals doji. So we're saying delete from the table where the symbol matches this cryptocurrency. So when we run this and we rerun this, we will notice that it's deleted crypto. It's deleted from the crypto table. It's deleted doji, right? So we're now left with one less number of data points. So this is another good way to query the data and also be able to delete any data that's no longer in use or is not required. So that brings us to the end of our very short tutorial. It's basically an introduction to SQLite in Python, and at the end we would like to run the connection.commit, which commits the data into the database, and then we can go ahead and close the connection, and that basically ends our tutorial as well. I do look forward to your comments, and I do look forward to creating another tutorial which may look into the advanced features of SQLite, which would include working with as an example with pandas, or creating a database in memory for some quick work. So we would cover those in a future tutorial.